Uno, dos, tres, cuatro.
Hi everyone, here's our final lesson for our logs chapter. It's part 3 of our applications. Today we're going to take a look at what happens when you have earthquake style questions, decibel style questions, and pH scale questions. They're very popular applications for using logs. So let's take a look at what we know about the Richter scale with an earthquake. So with the Richter scale, what it means by definition is every time you go up one full unit on the Richter scale, there's a tenfold increase in the intensity of the earthquake. And an example of that would be if you had an earthquake of, say, 8.0 on the Richter scale, and you're comparing it with an earthquake of 7.0 on the Richter scale, the earthquake that's 10.0 on the Richter scales would be 10 times as intense as the earthquake of 7.0 on that Richter scale. Now, what if you're to compare something like this? What if you're to compare that with a 6.0 earthquake and an 8.0 earthquake? So think about this. They're representing powers of 10. So to go from 6 to 7, you know that would be 10 times as intense. And then to go from 7 to 8, that's another 10 times as intense. So to go from 6 to 8, you would have to go times 10 times 10, and it would be 100 times as intense. Okay, so given something like that, are there some ways that we can start to find this out maybe a little bit more efficiently? So if we take a look at the example of the 8 and the 7, you could say something like this. I'm just going to erase this here. 10 to the power of 8 divided by 10 to the power of 7 equals 10 to the 8 minus 7, which is 10 to the 1, which would be 10 times as intense. So for part A here, we're just going to fill in a 10. And so anytime you have something like this, you could now just write them as powers of 10, where the magnitude is the exponent. And what you could start to do is, because you're dividing to find out how many more times something is than another, then you, based off of your exponential rules, if you're dividing with the same base, you can just subtract the exponents. So let's look at what would happen with something like part B. If you had something that was 7, a magnitude of 7, and you were finding out how many more times that is intense than a magnitude of 3, you could just say 10 to the 7 minus 3 equals 10 to the 4. If you wanted to, you could say that's 10,000 times as intense. You could probably just leave it as 10 to the 4, but that's what we get. So by definition, what would you say for something if you had an earthquake with a magnitude of 4 and you're comparing it to something with an earthquake of magnitude 6? So remember, now 4 would be only worth a fraction of what the 6 is worth. And so you could say something like this. You could say 10 to the 4 minus 6, which would be 10 to the negative 2, which is the same as saying 1 over 10 to the positive 2, or it would be 1/100th as intense as the magnitude of 6 on the Richter scale. Okay, let's look at a couple past earthquakes that we have here. So in 1985, there's an earthquake in Mexico, and if you take a look at that, that was 8.1 on the Richter scale, and they're comparing that with the 1970 Peru earthquake of 7.7 on the Richter scale. So for something like this, you could say 10 to the 8.1 subtract 7.7, which equals 10 to the 0.4. And then let's put that into our calculator so we can actually figure out something with that. So you could just go 10 to the power of 0.4, and you get something that would be approximately 2.5 times as intense. It didn't say what to round it to, so we'll just round it to 1 decimal place here. Now, if I was to say these first 4 questions were pretty straightforward, I mean, you could teach this to a grade 8 or grade 9 class, because this is just looking at basic exponential laws and powers of 10, and it hasn't used anything to do with logarithms. But clearly, if we have exponents, we could probably find a way to incorporate logs. So if you look at example E here, it's saying calculate the magnitude of an earthquake that's twice as intense as the 1989 San Francisco earthquake that was 6.9. So let's use an example of this past Peru, Mexico example, and let's figure out what we said with this. We know that 10 to the 8.1 minus 7.7 equaled 2.5 times as intense. So what we could say with this is we could line this up and we could say something like 10 to the power of what minus 6.9 would equal 2 times as intense. So just create that same sort of form, and now we're given our answer, but we don't know what the x value is for the magnitude of our earthquake. Given something like that, we could now easily put that into log form, and we could say log base 10, no, you don't need to write the 10, of 2 equals x minus 6.9, and we could add 6.9 onto the opposite side. And if you do something like that, then log 2 plus 6.9 is going to give us an earthquake magnitude of 7.2. Okay, so there you go. That's how you do earthquake questions. A second common application is sound and decibels. If you think about where you've heard decibels before, I don't know if maybe at a Canucks game or at a Seattle Seahawks game or something like that, sometimes they talk about the how loud the crowd is through decibels. And so here's a couple examples. And the decibels are measured where for every time you have a 10 decibel change, there's a 10-fold increase. And so we can look at some examples with this, but basically it's essentially identical to doing our earthquake applications, except that you would have to move for every 10 decibel increase rather than every 1.0 increase on a Richter scale would increase by 10-fold. What do I mean by that? So if we compare something like a power saw, which has 110 decibels, and we wanted to compare that with me laughing at my own joke, which is probably much louder than 80 decibels, but we'll say it's 80. And we wanted to see how many more times intense that would be. Well, going from 80 to 90 decibels, based off of the definition that we're given up here, would be a 10-fold increase. So then going from 90 to 100 would be a 100-fold increase. And then going from 100 to 110, it's another 10-fold. So now we have 10 times 10 times 10, you would have a 1,000-time increase. So we're saying that the power saw is going to be 1,000 times as loud as me laughing at a joke of myself. How could we calculate something like this using our algebra? Well, if instead of saying 110 decibels, you changed it to say something like 11.0 decibels, and you subtracted that from 8.0 decibels, you'd be left with 10 to the power of 3, which was 1,000. A jet engine at 20 meters is very, very loud, 130, 135, 140 decibels. And we're going to compare that with the threshold of pain, which is at 125 decibels. And if we want to compare those, we could say that would be 10 to the 14.0 subtract 12.5, and you could put that into your calculator and see what you get from that. So 10 to the power of 1.5. And from there, you should get approximately, it doesn't say exactly what to round it to, so we'll say 31.6 times as loud. Let's look at a whisper and a conversation. So if you have a whisper, here we have 30 decibels right here, and a conversation is up here at 60 decibels. And they're saying a whisper is blank times as loud as a conversation. Well, the whisper is going to be quieter than the conversation. So you could say something like 10 to the 3.0 subtract 6.0, which equals 10 to the negative 3, or 1 over 1,000. It would be a thousandth as loud. Okay, again, very similar to our previous examples for the earthquake applications. All right, what do we have? We have pH scales. I'm sure that you've studied this already, just in your different science classes. And I'm looking at this, and I see that we have some examples of lemon juice, tomato juice, water, baking soda, oven cleaner, and so on. And here we have, as we go to the left, we have acidity. As we go to the right, we have alkalinity. And at 7, we have our neutral pure water measurement right here. And so based off of this, again, there's really no tricks to it. For every 1 unit increase, it would represent something that would be 10 times as acidic or 10 times as alkaline, depending on which way you're moving through the scale. So if we take a look at our examples here, we can say something like this. So tomato juice, which is at 4.0, is being compared to water. Now, the one thing that is different about this is tomato juice more acidic than water? Yes, it's much more acidic than water. How many times more? Well, it's a 4 on the pH scale, whereas water is a 7 on the pH scale. And so what we could say with this is we could say it'd be 10 to the power of, and this might seem strange, but you have to do 7 minus 4 because it's going to be 1,000 times as intense. As acidic, not as intense. Going from 4 to 7 means that going from 4 to 5 would be 10 times more acidic. And actually, I should go backwards here. Going from 7 to 6 would be 10 times more acidic. Going from 6 to 5 would be 10 times more acidic. And then going from 5 to 4 would be 10 times more acidic. So then overall, you would be 10, 100, 1,000 times more acidic. Depending how far you go over, it keeps getting more and more acidic by tenfold increases. So there we have 10 to the power of 3. Okay, we got baking soda. I got baking soda. So if this has a pH measurement of 10 and you're comparing it to lemon juice, which has a pH of 2, you're going 8 units over here. And it wants to know how many more times alkaline is baking soda. And we know that the higher the pH reading, the more alkaline something is. It's way more alkaline. It's 10 to the power of 8 times more alkaline, because it would be 10 to the 10 subtract 10 to the 2, divided by 10 to the 2, which is just saying 10 to the power of 10 minus 2. Let's see what we could do with some of these other questions here. What if they say something about oven cleaner and baking soda? So oven cleaner is a 12 and baking soda is our 10. We could answer this question 2 different ways. So we know that going from 10 to 12 would be something that would be 100 times more alkaline. The level 12 is 100 times more alkaline than the level 10. So you could say something like this. Oven cleaner is 100 times as alkaline as baking soda. But you could also say something like this. Oven cleaner is 1/100th as acidic as baking soda. So there's multiple ways to be able to answer this. And so just know that you could answer it either way. Both ways would be correct with that. Okay. Part D, what would be 100,000 times as acidic as pure water? Well, let's look on our scale. 6 would be 10 times, 100 times, 1,000 times, 10,000 times, 100,000 times. It would be lemon juice. All right, and that's 10 to the power of 5. You could have got that by saying something like this, if that helped. So we must have a reading of 2.0 on our acidity scale. Okay, one final overall example. Here's some earthquake questions right here. One earthquake is 275 times more intense than another earthquake. If the lower intensity earthquake has a Richter scale reading of 4, what was the Richter scale reading of the higher intensity earthquake? 10 to the power of something, subtract 4 equals 275. Put it into log form. Log base 10 of 275 equals x minus 4. Add 4 onto the other side. let's see what we have right here. So log 275 plus 4, and we get 6.4 on the Richter scale. All right, that's our final part on applications. Now, depending on what we said in class, for my class, we're going to say let's not worry about these, but there are some really, really good practice problems here. And so if you go through some of these practice problems, I think you'll find them to be very thorough, and you'll have a good chance to be able to practice all the different types of applications from the 3 different lessons that we had this past 3 lessons. All right, that's it for today. Thanks for joining us.